Hi everyone, welcome. This is Terence, and in today's video, I'm going to introduce how to create this set of twisted vases by RhinoPython. Just a little bit coding. You don't even need to open the Grasshopper. And in this video, I will talk about some ideas like how to generate point metrics with the dictionary, how to transform circles with the Python's random function, and how to generate the geometries with some of RhinoScript syntaxes. So let's get started. So at first, I want to break the whole process into 3 steps. The first step is to generate this set of 3D point metrics. Then we can grab these 8 points as a module, and based on this module we can create our units, which enables us to repeat it horizontally and vertically to create this set of stacks. Then the second step is to draw some circles, is to work in our modules. Then we can just try to draw a circle and another circle on the back. Then the third step is just to transform them to make them narrower, and maybe make another one narrower in another direction. Then loft them into a geometry. So this is our basic idea. So let's get started to create the point metric at first. So first, we need to import our RhinoScript syntax into our workspace and Rhino workspace as well. So import RhinoScript syntax as RS, and this is a universal way to import RhinoScript syntax, and you can see it in many tutorials and many other videos. Then we need to define a function to generate the point matrix. This function takes 3 parameters. The first one is how many points along the x-axis. The second one is along the y-axis, and the last one is how many points along the z-axis. Then inside this function, we need to declare an empty dictionary. So we call it pt matrix equals to an empty dictionary. Then we just loop over all 3 directions. So for z in range zmax, and for y in range ymax. The last loop for x in range xmax. Then we just insert the point into the point matrix. Then we can say pt matrix with a key x, y, z equals to the coordinate x, y, z. So this part is just a key, and this part is the real coordinates that we use to generate point. So to distinguish them from each other, I want to multiply by 8 in the coordinate tuple. So after this loop, we already generate the point matrix. Then the next thing is we need to show these points in our Rhino space. So we can use a function called rs.addPoints. Add points. Then to convert the dictionary into a list, matrix.values, okay, and convert it into a list. Okay, so we basically finish this function. Then we can try it out. Then we can define the x max value as maybe 6. The y number of points in y-axis as 2, and number of points in z direction could be 6 as well. Then we run this function, generate matrix x max, max, y max, and z max. Then we can run this code. Okay, the points are successfully generated. And in some condition, we just need value. We don't really need the point to show in our workspace. So we can just add one more parameter here. We call it show points. And by default, this should be false. This could be false, not should be. So let's run it. Okay, so sorry, I haven't added the code here. We can say if show points. If the show point is true, we generate points in the space, or we just store those points in the memory. So we remove this, then run this again. Now we can't see any points because we don't do the point. We don't generate points in space. But actually, those points are in our memory, so we did have those points, but we're just not showing them. Then at last, we can return this PT matrix, and here we can say PT matrix equals to generate matrix. So at this time, I want to keep it true. So we just finished our first step. Now let's go back to our point matrix, our module. The module consists of these 8 points. Then we can first try to label these 8 points. So if we make this one as as an original point, so we label it as x, y, and z. We take this as x-axis, this as y-axis. So this point could be x plus 1, y, z. This point could be the x, y plus 1, and z. So this one is x plus 1, y plus 1, and z. So this is the first layer, and the second layer here is basically the same coordinates as it's in below, but with an z plus 1 here. And this one is x, y plus 1, and z. And this point is x plus 1, y plus 1, and z plus 1. Oh, we still have this one, x, y, and z plus 1. So we can use these keys to retrieve the point in our dictionary. So in this condition, we can think about how we could draw a circle inside this matrix. So if we draw it in the x phase, I say it x phase, actually it's along the x direction, x-axis. So we can use another color, yellow. And if we draw the circle inside this part, sorry, I want to make it looks better, inside this part, and we can find the 4 vertices control this circle is this one, this one, this one, and this one. So the same rule applies to the back face here. So we can think about this. 4 points that construct this circle is the x, y, z, then plus the x plus 1, y, z, plus the third point here, x plus 1, y z plus 1, and the final point is x y z plus 1. So these 4 points helps to construct the first layer of our circle. And okay, so let's show it in the Rhino space. So in this condition, this is our base point. This is x plus 1, y and z, something like that. So we can draw this module to show how this works. Now we want to generate curve in this side and this side. So type in the curve, should be start from here, the second point, third point, fourth point, and make it close. So this is our point. The same rule applies to the back side. 1, 2, 3, 4, and close. And close it. And then let's try to make this curve through our code. Let's define another function called generate curves, which takes 4 parameters. The first one is the point matrix, then x max, y max, and z max. So inside this function, we need to first declare an empty dictionary called curveDict equals to an empty dictionary. So let's take a look at this point matrix. So our curve distributed on the x and z plane. So in this condition, this could be the first layer of curve. This could be the second layer of curve. So we want to separate these layers by the y-index. So we can generate two curve lists or 2 layers inside this new dictionary, new curve dictionary. So we loop over the y value for y in range, y max. Then we generate empty list in this dictionary called I equals to the empty list. Then we can add the curves add the curves into the dictionary according to their y value. Okay, so let's loop over all 3 axes. I want to first start from the y axis, y in range, y max, and for x in range, x max, and for z in range, z max. And something should be cared about here is in the y max and z max, the value should -1 because let me bring this sketch up. Because when we are looking over here, there is no point in these 2 directions. So if you don't -1, when the points loop here, there will be an arrow here. So the code can't be functionally executed. So here is the trick. Then we can just select the point we need. So the point A is our basic point. Oh, let me bring this up again. Here is the reference. So the basic point is x, y, and z. This is a tuple. The second point, PTB, is point B is matrix x plus 1, y, and z. PTC is matrix x plus 1, y, z plus 1, and the last point, PTD, is matrix x. y and z plus 1. Okay, these are all our points. Then we want to create a list to contain this point. Then we can use the points to generate a curve. So we create a list called points, PTA. The sequence is very important. PTB, PTC, and PTD. And here's another trick. We should put PTA at the end of this list because we want to generate a closed curve. So a closed curve requires the start point and the end point are identical. So we put the first point into the end of the list. Then we can just generate the curve equals to rs add curve PTS. Then we append this curve into the dictionary. So curve dictionary y dot append CRV. At last, we return this curve dictionary, and let's try it out. We should remove this and equals to generate curves, the matrix, PT metric, X max, Y max, and Z max. Okay, let's run the code. Okay, it works. So by here, we just finished our second step. Then we can try to loft curves to create the geometry. So let's take our first module as example. What we want to loft are these two curves. So this geometry is what we want. Then we can think about our curve dictionary as the data structure of our curve dictionary. These curves locates in the first layer and these curves locates in the second layer. So we can use this, we can take advantage of this structure to loft all the curves. Then we can just define another new function called loft curves that requires the curve dictionary parameter and how many layers of curves. So here our layers are y max. Then we create an empty list result to contain all the lofted geometries. Then what we want to do is to loop over all the curves in our first layer, then loft them with all the curves behind each circle in the first layer. Like we loft this with this, we loft this one with this one. These are just examples. Then we need to loop over all the circles. We can say for I in range the length of the curve dictionary 0. This is the first layer. Then for example, now we have this one as our start point. We want all the circles behind to add into a list. Then we can use the curve list to loft this geometry. So we will need another we call it the list comprehension to put the circle has the same index but in the different layer into a same list. Then we can loft those curves in one time. So we say curves equals to curve dictionary, the sorry, it's not. This should be y. Index of the curves for y in range y max. Then the result append to loft. Then we can just loft those curves and append it into the result add loft surface, put the curves inside it, then we return this result. And let's try it out again. Surfaces equals to loft curve, curve dictionary, and y max. Let's delete all of this, then run the code again. Okay, it works. Then we finish the basic structure of this pattern. The next step is we add a little complexity, add a little randomness to make these tubes looks more dynamic. And then we need to import the random. Here you can say from random import a function, which is also called random. This function generates a random value ranged from 0 to 1. The result will be a decimal value. Then we can define a new function here. We call it scale curve. Take 3 parameters: the curve itself, the maximum scale 1.1, and the minimum scale factor, maximum scale factor, I think. The first thing we want to do in this function is to find the center of each curve, because every scale based on a center point, or if you don't provide center point, every scale takes place according to the original point. So the first step, we find the center point. The center point equals to rs dot curve area centroid, which takes just one parameter, the curve. But be noticed here that this function actually returns a tuple, a point, and a vector. And today we only need this point. We don't need this vector. Maybe we will talk about this vector later. But today we just let it be a point. And then we can generate a random x factor by the random function we just imported. We can say x factor ctr equals to random. And now the x factor will be a random value between 0 and 1. But actually, we hope the random value locates between the 1.1 and 0.5. So we need to add a little computation, that max minus minimum plus minimum. So this equation helps us generate a value between 1.1 and 0.5. Then the z factor is the same, equals to random multiplied by max minus minimum plus minimum. Then based on these values, we can start to scale our object, scale our curve. Curve origin is center, and the scale is the tuple, which we can use a parenthesis and put x factor, y factor. We don't want any transformation happens in y axis, so y factor could be 1, and z factor we already declared. Then this is our scale curve function. Then we just need to insert this scale curve function into the generate curves function, just a line behind the curve generated, like scale curve, and insert the curve here. And now let's try it out. Okay, it works. Then at last, we can just to modify the values here to generate the tubes or the twisted vases. as we want. So we delete this, and now we no longer need those points. We can just remove this and add the layer of curve to 3. This may be 8, and this could be, could maybe make it 6, and run this code again. And now we generated what we want. Generate the curve, we generate the geometries we want. And in terms of rendering, I actually created this rendering by this V-Ray render in Grasshopper because the Grasshopper provide me with many methods to create dynamic materials. Then I can apply these materials to the vases we just created. But I don't think this topic is within today's scope, so I will not talk about this. But if you guys are interested, please let me know, and I will create another video talking about how I generate this rendering by the V-Ray render Grasshopper. And I will put the code in the GitHub repository, and you can find the link in the introduction, in the video's introduction. And please let me know if you guys have any thoughts, comments, or even critics. I'm super welcome in this because I am still a learner of RhinoPython, a learner of English, and a new YouTuber. I really want to hear. I really want to hear about what you think. And that's it for today's video. Thank you so much for watching, and have a nice day.